This is the simplest form of the web app. In the center, you see the raw data of a previously run experiment. It was recorded through a microscope eyepiece. These black objects are the microorganisms. On the sides, yellow bars pop up. They indicate where the light shines from and how bright. You can look at other experiments, of course. This new experiment, for example, uses brighter light than the one before. We can activate automatically generated visualizations of the video data. For example, in this visualization, you see the proportion of microorganisms that move in each direction at every moment. This other visualization shows the average and variation of the forward speed of all microorganisms. Because these visualizations are automatically generated, when you load a new experiment video, the visualizations get updated too. Things get much more interesting when you can run your own experiments. Let's say we want to gradually increase the brightness of light that shines from the left. We choose elements from the experiment menu accordingly. If the same experiment has been run previously by someone else, the web application loads that experiment instead of running a new one. This saves time. Once it's ready, you can load the data of the new experiment. Finally, the web app allows students to build models and test against real data, to study how the microorganisms detect and react to light. Here's a simple model. It has a light sensor, shown in red, like a simple eye, and a motor. We call it flagellum. This motor can make the euglena move forward at different speeds, turn left or right at different speeds, and rotate around its axis at different speeds, like a spinning football. When you click on Run Model, the system simulates 10 model euglena in the same visual space as the real ones. They're shown here in blue now. Wow! But you see that it's a really bad model, because the simulated euglena don't do anything. That's because we haven't told them yet what to do with that body. Well, we can do this with a simple block-based programming interface. We can create a model that moves forward at the speed we defined just before on the left, and that rotates around its axis at all the time. Then we can tell it to turn away from the sensor when it sees light, and thus turn away from light. Well, the simulated euglena of this new model behave more realistically now. We can compare the model and the real euglena, both in the different visualizations and directly in the videos, and we can see how good of a model we built. And making a small change to the model is easy too, like here. We can make it move towards this light instead of against it, run the simulation again, and then see how they move towards the light now.